All right, good evening, everyone. This is Eric. I will be leading your week 3, day 2 lecture today. Yesterday, for day 1, you guys learned about Docker and containerization. Today, we will be getting into some AI with some AWS Poly, turning text into speech. So, speech audio. So, it's going to be a pretty fun lesson. And if there's no questions, we can go ahead and get started. All right, so day 2, AWS Console and CLI with Poly. What are we trying to accomplish? Today's goal is to master the end-to-end workflow for converting text into professional quality speech using AWS Poly. We'll explore this powerful service through primary methods used by developers, interacting with the AWS console, and scalable automation via the command line interface. You will learn not just how to generate audio, but how to customize it with lexicons for correct pronunciation and SSML for fine-tuned control, preparing you to integrate voice capabilities into modern applications. So SSML allows you to uh, pretty much dictate how fast uh, the voice is reading the text or what the pitch is for the voice, amongst other things. We will get more into it. Learning objectives. By the end of this day, you will be able to explore and compare different text-to-speech voices and engines, standard versus neural, using the AWS console. Generate audio files from text programmatically using the CLI. Create and apply custom lexicons to ensure correct pronunciation of technical terms and jargon. Use speech synthesis markup language to control speech characteristics like emphasis, pauses, and rate of speech. And automate the conversion of multiple text files into audio using a batch processing script. So we can go ahead and get into our lesson. We have a lesson and then a lab. The lesson is mainly going to touch on all the different components within AWS Poly. So it's not going to be as hands-on, but we will get to that within the lab and we'll create some cool audio. So let's go ahead and get into the first lesson. So yesterday you guys learned Docker to containerize Flask and Postgres. Now we're ready to plug a front-end application. What better way to do this than AWS Poly? Uh, and how to interact with it through the console, through CLI. What makes Poly different? AWS Poly expands on basic text-to-speech systems that have been in use for quite a while now. So think of maybe like voicemail or whenever you call a business that's closed, they'll redirect you and say, hey, we're closed, please call back again tomorrow, something like that. Uh, you've probably heard these at some point, and you can probably recall how robotic they sound. With AWS Poly, you're able to tap into deep learning to create human-like voices with natural inflection, breathing patterns, and emotional nuance. Traditional text-to-speech systems sound robotic because they assemble words from pre-recorded syllables. Poly generates speech dynamically, understanding context and applying appropriate emphasis. The difference is immediately apparent when you hear it. So the building blocks, there are many ways to customize Poly, and these include voice engines, voice selection, lexicons, which it fine-tunes pronunciations, SSML, which is additional fine-tuning through markup language, and output file types. So for voice engines, we have standard and neural. Poly offers two engine types, uh, which is what I just said. They both have different use cases. So for standard voices, it's faster processing, lower cost, good for basic announcements or large volume applications. It's reliable but less natural sounding. You'll get more of that robotic voice. Neural voices is higher quality, more human-like, better for customer-facing applications, slightly higher latency and cost. Think of it like video quality settings between 720p and 4K. Standard voices are like 720p, perfectly functional for most purposes, and neural voices are 4K, which is noticeably better when quality matters. Voice selection strategy. Poly provides dozens of voices across multiple languages. We'll see that in just a moment when we go to the AWS console. We can see the different uh, voices or people names you can choose from. Your choice depends on your audience and use case. So for professional applications, Matthew or Joanna would be the go-to choice. For corporate content, customer service, you can choose Amy for a friendly, more approachable tone, and she does have a UK accent. Accessibility, clear, slower voices like Emma. International, match uh, voice accent to your user base. So lexicons, this is one of the first main components to help you create those differences within the speech. Every organization has unique terminology, product names, acronyms, technical terms. Poly's lexicons let you teach the service how to pronounce these correctly. So, for example, if you have something uh, written out as AWS within your text, the lexicons will be able to uh, help AWS Poly or the voice uh, say Amazon Web Services instead of AWS. So it'll look for those specific terms you give it and replace it and pronounce it to however you want it to. So mispronounced company names or technical terms immediately signal to users that your application wasn't built with care. They create unnecessary distractions that weaken the user experience. Lexicons solve this. Multiple lexicons can be applied to synthesize text, and they can be reordered in terms of priority. We're going to get into two examples right here. Uh, these are two poly XML files. They both define lexemes, which is the tags you're going to be using within your XML file, or word entries with the written form of a word using the grapheme tag, and the alternate pronunciation we want using the alias tag. So for example, if the text has Bob, this first example will have the voice say Robert every time it comes across uh, that specific word Bob. For this second example, since we have Bobby in the alias, every time it sees Bob, it's going to say Bobby. Alternatively, we could construct poly to replace Bob with Bobby. Lexicons will have much more complexity than this, so you might find yourself wanting to utilize multiple lexicons rather than creating a new one that entirely that picks and chooses lexemes from each lexicon. That can be tedious. You'll still have to be mindful about where the overlaps are between the multiple lexicons that you have, and you'll have to be okay with one always taking priority over the other. If the lexicons are listed in the order Lex A, then Lex B, the synthesized speech will of course take the first one, Lex A, which had Robert. And if they're in the opposite order, so Lex B, then Lex A is going to change Bob to Bobby. And this is the uh command format that you will run on your CLI to generate these audio files. So you run the AWS Poly synthesized speech, you give it the XML files, you specify your output format, and then your text, and you're choosing your voice ID right here for Justin. Same thing with this one, but the lexicons are flipped. So you have for this one, it's going to say Bobby instead of Baba. Lexicons give you consistency and pronunciation, but what if you want dynamic sentence level control, pauses, emphasis, or emotional tone? That's where SSMLs come in. So SSML stands for speech synthesis markup language, and it gives you a director level control over speech output. Think of it as an HTML audio tags that control how text gets spoken. So common uses of SSML, adding pauses for emphasis or pacing, speeding up or slowing down specific sections, adjusting overall speaking rate, pitch, and volume, emphasizing important words, controlling pronunciation of numbers and dates, insert breaks, whispers, or breathing effects depending on your voice support. SSML transforms robotic announcements into engaging professional communication. The difference between your order total is $23.47 and your order total is $23.47. Might seem small, but it significantly impacts user experience. So for this example, during the SSML, you probably just added a break right here to create that dramatic effect. So here's a simple SSML example showing how you might transform a robotic statement into something more conversational. And yes, it just adds the break time for 700 milliseconds, and it gives an emphasis level of moderate to emphasize the total. Here's another example. So it's saying it wants the rate of the speech to be slower and then the pitch to be higher of the voice. It gives you a break of 500 milliseconds. Then it turns up the rate to something faster and puts the pitch down. This is less intuitive, using less common words such as prosody. This is where we'll remind you how documentation can be an engineer's best friend. Let's go ahead and click on that real quick. So for any questions you may have regarding Amazon Poly, you can visit this documentation. If you want to dive deep into it, go through all this documentation to the side right here. Overall, you can combine SSML and lexicons for maximum control. Lexicons handle recurring terms, while SSML fine-tunes how entire sentences sound. SSML is written in XML syntax. You can store it in any plain text file. Commonly, you use .ssml, .xml, or .txt, as long as it contains valid markup. And then these files are then simply passed into Poly when calling synthesized speech, that command that you guys saw earlier. So you're running the command AWS Poly synthesized speech right here, giving it the flags for the text type to be SSML. You specify the text that you want, and this is giving the CLI a file called example.ssml, and then you choose your voice ID from AWS, which we're using Joanna. You specify the output format you want, and then you specify the output name. Any questions so far? Audio formats and quality. The last configuration we'll mention is one that doesn't need much introduction or detail. The key thing to know here is that Poly supports multiple output formats, MP3, OGG Vorbis. I've never actually heard this or used this before, and WAV files. So MP3 is a universal compatibility, good compression. OGG Vorbis is open source, excellent quality to size ratio, and WAV files are uncompressed, highest quality, but they're very large files. Your primary concern when selecting between options is to consider your use case. Most applications use MP3 at 22.05 kilohertz sample rate, the sweet spot between quality and file size. Only choose higher quality when audio fidelity is critical, like professional podcasts or accessibility applications. Employment context, voice-enabled applications aren't optional anymore. They're expected. Accessibility regulations require audio alternatives for text content. Customer service increasingly uses automated voice systems. Content creators need efficient ways to convert written material to audio. These trends create opportunities for developers who understand voice technology, and companies need people who can implement Poly effectively, not just use it casually. So today's skills prepare you for roles in front-end development, for voice-enabled web apps, DevOps, automated audio generation pipelines, accessibility engineering, compliance solutions, and customer experience for voice-enhanced interfaces. Any questions on that first lesson? Anything about lexicons, lexemes, uh, different engines? Good to go. We're gonna go ahead and get into the lab then. So let's go ahead and continue. So today's lab will be hands-on exploration of AWS Poly through both the web console and the command line interface. You'll create audio files, customize pronunciation, and understand the workflow for voice-enabled applications. By the end of this lab, you should have explored Poly voices through the AWS console, generated audio files using AWS CLI, created and uploaded custom lexicons, applied SSML formatting for enhanced speech control, and built a foundation for programmatic voice integration. You should be able to choose appropriate voices for different use cases, generate professional quality audio from text, customize pronunciation for technical terms, and automate audio generation through the command line. So part one, we're gonna go into the AWS console first. So before diving into CLI commands, let's understand Poly's capabilities through the web interface. It's going to be straightforward and give us a chance to try out different configurations like voice selection, which we can't really do as quickly within the CLI. You'll have to uh, get a list of all the different voices that you have, and then run that command with that specific voice and pretty much keep on alternating to figure out which voice you would want. Whereas in the AWS console, it specifically tells you all the different names from a little drop-down menu. So let's go ahead and log into the AWS console. Let me move this to a new window. Okay, so go ahead and sign into AWS. Just give me a thumbs up when everybody's over there in the home screen. All right, sounds good. So now we're going to go ahead and look for Amazon Poly. I already have it saved to my favorites, and you can do that just by so if you're searching for Amazon Poly, just go ahead and click the little star button to the side. The main ones I really encourage for you guys to save our EC2 S3 IAM for right now. So let's go ahead and go to Poly, open up the little side panel right here to the left. Go to text to speech. And go ahead and copy the text that's within the lesson. I'll also put it in the chat. And just go ahead and put that text within the input text box in your AWS console. So let's go ahead and test out a couple of these voices. So first one we want to take a look at is Joanna. She's running the neural engine. So again, that's the neural engine sounds way better than the standard engine. So this is going to be a more professional female voice. So Joanna. Once you click Joanna on the right-hand side for the voice, you can go ahead and press listen. You have three different options up here. You can save it to an S3 bucket. You can download it or listen, but for now, just click that orange button.
Welcome to our DevOps documentation system. Today we'll cover AWS API development and PostgreSQL database management.
There you have it. It's pretty cool. Technology's crazy. Second one we want to take a look at is Matthew. He's running on a neural engine as well, but this time it's going to be a professional male voice. Go ahead and press listen.
Welcome to our DevOps documentation system. Today we'll cover AWS API development and PostgreSQL database management.
Let's go ahead and try switching it to the neural engine. We were just on generative, so generative produces the most expressive and adaptive speech using generative AI. And then neural just produces more natural and human-like speech compared to the standard engine. Really, for this text, what I want you guys to pay attention to is the pronunciation of things. One word to keep a look at is the pronunciation of PostgreSQL.
Welcome to our DevOps documentation system. Today we'll cover AWS API development and PostgreSQL database management.
Notice how it sounds different compared to how he says PostgreSQL is way different using the generative engine. So let's play it again one more time.
Welcome to our DevOps documentation system. Today we'll cover AWS API development and PostgreSQL database management.
Let's go to generative.
Welcome to our DevOps documentation system. Today we'll cover AWS API development and PostgreSQL database management.
Notice also how generative engine has a longer break between the commas. Next thing we want to do is check Amy. To find Amy, she's not going to be in English, so English US for the language. So you're gonna have to click that left drop down and find English British. First one that pops up should be Amy. Let's go ahead and put it to the neural engine. Listen.
Welcome to our DevOps documentation system. Today we'll cover AWS API development and PostgreSQL database management.
Next, let's go ahead and try Justin. He's going to be running on a standard engine. So let's go ahead and switch back to English US. And he is towards the bottom. So let's go ahead and listen.
Welcome to our DevOps documentation system. Today we'll cover AWS, API development, and PostgreSQL database management.
Notice how it sounds more robotic compared to the neural. Let's try to see if we can listen. There's a difference.
Welcome to our DevOps documentation system. Today we'll cover AWS, API development, and PostgreSQL database management. Welcome to our DevOps documentation system. Today we'll cover AWS, API development, and PostgreSQL database management.
Let's go back.
Welcome to our DevOps documentation system. Today we'll cover AWS, API development, and PostgreSQL database management.
Also, I don't know if you guys can hear it, but the neural engine kind of sounds more smoother compared to the standard engine. The standard kind of is a little bit more choppy. So look how smooth it is.
Welcome to our DevOps documentation system. Today we'll cover AWS, API development, and PostgreSQL database management.
And then now look at the standard.
Welcome to our DevOps documentation system. Today we'll cover AWS, API development, and PostgreSQL database management.
So again, what I wanted you guys to pay attention to was the pronunciation of the technical terms AWS, API, PostgreSQL, the natural flow and inflection, and the overall professional quality. And we did it's kind of hard to tell, but there is a difference. So the professional quality between neural and standard for Justin that we just went over. So now that we messed around a little bit with the hold on one second. So now that we went over going through the AWS console, we can go ahead and start using the CLI, see how to do things from there. Any comments, questions? Okay. So go ahead and open up your terminal. We're first going to be creating some directories. So go ahead and create a directory called polyfundamentals. Do make their polyfundamentals. Do an ls to make sure it's there. Go ahead and cd into polyfundamentals. There shouldn't be anything in here. I just kind of have a habit of doing ls every directory change. Within polyfundamentals, you're going to create 3 more directories. So just do mcdir. You're gonna have a directory for our audio outputs, for our lexicons, and for our test files. So if we do an ls, all 3 should be there. Audio outputs, lexicons, and test files. We were mentioning earlier how exploring the different voices is easier through the AWS console because you have that drop-down menu. Right now, we're going to go ahead and retrieve all our available options within the CLI. So for that, you just run AWS poly, describe voices, throw in a flag called language code, and we're looking at everything in English US. Go ahead and press enter. First things first as well, make sure you have the correct region and correct profile. So you can run that by doing AWS configure list. Okay. Oh, okay. I see I had a typo. So you should get a JSON back, and it has a key of voices, and then within those voices you actually have the different options that you have along with different attributes. So for example, for Danielle, specify the gender female, the language code, language name, and supported engines. Notice how Danielle supports generative, long form, and neural, but Gregory only supports long form and neural. Patrick only supports long form. Joanna supports generative, neural, and standard. So it's good to pay attention to what engines each voice supports for your specific use case. So to get out of this screen, you just press Q to quit. Now we're going to go ahead and create our first audio file. For this, you can either use code to create and open a file in your editor for easy copy pasting, or you can just generate one quickly from the command line. For me, I'm just going to go ahead and generate one from the command line. I'm going to use it's peanut butter jelly time text. So I'm not going to type that all out. Just going to go ahead and paste it. But this is pretty much saying to insert this text within this file name, and it gives you a label, EOF, which stands for end of file. Go ahead, Kevin.
Yeah, I'm a little lost, Eric. Where are you? What repo or folder did you create the Poly fundamentals in? Because I see you have DevOps AI Delta cohort. Where are you?
So you can honestly create in whatever directory that you need,
Uh,
or whatever directory that you use. So the way I set up my projects is if I go back to the root directory
mhm.
and do an ls, this is where I have everything, but I specifically have a coding directory. So I cd into that code,
Okay.
and then this is where I actually have different folders for different things. And yeah, I just created a specific directory just for this class. I don't, yours might be set up different. It's really up to the user, so it's user preference where you want to store these things. I just like to have a coding directory so that I can keep everything separate and organized within my system. Does that answer your
Okay,
question?
and you specifically made the DevOps AI Delta cohort one. That wasn't one already in there. You made that, right?
Yeah, I made this.
Okay, thank you.
Yep.
Sorry. Okay, perfect. I got it now.
Yep. So this kind of just like for like a directory for class that I made. So I've been using this for our other lectures too, but I just delete the different directories that I created here. Uh, you good to go, Edison? Or was it Kevin?
Good to go. Thank you.
Yep. All right. So let's go back to our poly fundamentals directory. So as long as you have the poly fundamentals directory, and then within that directory you create the three other directories: audio outputs, lexicons, and test files, you're good. All right. So we're creating a text file. that has it's peanut butter jelly time song. And this command is pretty much saying within this text file, test content, we want to insert this text. And this label stands for end of file. And it's just saying everything after this, EOF within single quotes, I want to insert into this specific text file up until it reaches that second EOF. So if we go ahead and press enter and run this command, and we do an ls, we should have a test content file. Let me see if they wanted this in a different directory though. Let's create your first item. Okay, yeah. Yeah, so you should have your test content file within the Poly fundamentals directory. So after you create that file, you have your text within it. We can go ahead and call the AWS Poly synthesize speech command. So let's go ahead and type it out. AWS Poly synthesize speech. This is the actual root of the command. We will go ahead and press or give it a backslash, which means to continue the command onto the next line. So whenever you see this at the end of certain lines, that's typically what it means. If you press enter, it doesn't run the command. It just gives you another line so that you can input more commands or flags in this case. So the first one we are going to try is using Joanna. So the first flag we want is the text. So usually for this case, you're not going to be using a relative file path. So something that looks like this. And the reason for that is because that text flag, it counts everything after it, what you feed it as text. So if you gave it this, if you gave the text flag this context, is going to read it as ./test/content.txt. It's not actually going to retrieve the text within that file. In order to actually get the text within that file, you have to specify a file, 2 forward slashes, give it the name, .txt. And this special, what am I looking for? This special way to do it tells the CLI to retrieve the text that's within this file, that using this specific format. Any questions on that? So we're gonna go ahead and give it another backslash. Just do a voice ID for Joanna. Going to give it the engine. We're going to use the neural engine. We're going to specify the output format flag. We're going to specify as MP3. Do a backslash. And then we will specify where we want to store it as and the name of it. So we're going to store it in our audio outputs directory. Once you got that all typed out, go ahead and press return. Oh, I forgot the two dashes. What else did I forget? Put a space between text. Okay, what else? It was polysynthesized. Trying to see if I miss. You guys see any typos?
Audio outputs doesn't need two dashes in front of it.
Oh, okay, yep. Because that is the directory you're specifying, so good catch. So once it successfully runs, you'll get a JSON back. Just press Q to quit. The request characters counts how many characters are within that text file, and then also specifies the content type, so it's an audio file. So just go ahead and press Q to quit. Let me go ahead and clear this up. And then let's go ahead and ls the audio outputs to make sure that it is over there. So once I typed audio, I'll just press tab and it should autofill it for me. And we do have a Joanna MP3 file. Let's go ahead and type out the other one. Make sure you are in your Poly Fundamentals directory because when you try to run it, you might get an error if you're still in your audio outputs, or if you CD into your audio outputs to check for the Joanna file, because the text file is not within there. So make sure you're in the same directory as the text file. For the second audio file, we're going to be using Matthew. We're going to be using the neural engine as well. Specifying an MP3 output. And then specifying the location you want to save it to, as well as the file name. Go ahead and run it. Nothing should change. We can go ahead and run the ls audio puts. You can just press up probably twice to get to it. And we have two audio files within there. So now we can actually listen to it and compare it. Let's go ahead and CD into our audio outputs directory. Or you can just run it from your Poly Fundamentals directory using CD audio outputs / your specific file. So let's go ahead and code Joanna. Open that up in VS Code. And it should give you a little player of what it generated. Go ahead and press the play button.
It's peanut butter jelly time. It's peanut butter jelly time. Do the peanut butter jelly. Peanut butter jelly. Peanut butter jelly. Peanut butter jelly with a baseball bat.
Again, so for these audio files, listen for pronunciation, natural flow and inflection, and overall professional quality. So let's listen to it one more time.
It's peanut butter jelly time. It's peanut butter jelly time. Do the peanut butter jelly. Peanut butter jelly. Peanut butter jelly. Peanut butter jelly with a baseball bat.
So it's not the best, but it still sounds kind of robotic, but I'm sure it's way better than the standard engine. Now let's go ahead and listen to Matthew's recording.
It's peanut butter jelly time. It's peanut butter jelly time. Do the peanut butter jelly. Peanut butter jelly. Peanut butter jelly. Peanut butter jelly with a baseball bat.
So these are our two audio files with no lexicons or any modifications done to it. Let's go ahead and continue with the lab, see what else we create. So let's compare it with a standard engine. We're going to cd back into our poly fundamentals directory, and then just find that same code that you used for Joanna and just modify the engine to standard. And then after you change the engine, also change the file name from Joanna Neural to Joanna Standard. Go ahead and press enter to create it. Still an audio file, still has 171 characters. Go ahead and press Q. Let's go ahead and open that new audio file that we created so we can compare both Joanna audio files that we created. So code audio outputs and then Joanna standard .mp3. Press enter. Go ahead and play the standard, and then we're gonna go ahead and listen to the neural again afterwards. So just try to pay attention to the differences and see if you can notice any.
It's peanut butter jelly time. It's peanut butter jelly time. Do the peanut butter jelly. Peanut butter jelly. Peanut butter jelly. Peanut butter jelly with a baseball bat.
Play it one more time.
It's peanut butter jelly
and then I'll play it
time.
now.
It's peanut butter jelly time. Do the peanut butter jelly. Peanut butter jelly. Peanut butter jelly. Peanut butter jelly with a baseball bat.
Now let's try the neural.
It's peanut butter jelly time. It's peanut butter jelly time. Do the peanut butter jelly. Peanut butter jelly. Peanut butter jelly. Peanut butter jelly with a baseball bat.
Can someone tell me what differences they notice between the two? And if you don't notice anything, say that too.
Joanna Neural definitely sounds a lot better than Joanna Standard. I feel like the Standard has more starts and stops. Seems kind of like an unnatural way to speak. Neural is a lot more natural, though still kind of strange.
Mm. Yeah, I agree. It's and the neural one just seems a lot smoother as she's speaking. And yeah, the standard kind of just seems a little bit more choppy.
Yep.
The newer has a little bit more fluidity, where
Mhm.
it is choppy, the standard, yeah.
Yeah. All right. We can continue on with the lab. Next thing we're going to get into is creating a custom lexicon. So go ahead. Is everybody on the lesson? Do I need to paste that lexicon file in the chat? If you need it, just reach out. So again, we're just putting all this text within our dev terms.xml file. And inside we have so AWS Poly is going to look for the words AWS, API, PostgreSQL, DevOps, and JSON. And then I think you say it phoneme. I'll say phone me. But what's inside within this certain tags is the actual phonetic characters or the pronunciation of how you would say everything. So this sounds like A, this sounds like W, and then S. API, A, P, I, Postgres, Q, L, and then Dev, Ops, and JSON. I'm actually going to give you guys some resources in the chat of some different uh, uh, websites that contain help with some of these phonetics. You can also use ChatGPT or any AI service to help you with creating the phoneme because I feel like that's a little bit difficult to try and figure out which characters you need. Where's the chat? So here's the first one. I really do like this PDF compared to the next one I'm about to give you. And if you find any other better sources, just send it in the classroom channel. Okay, so go ahead and run this specific file to create it, or specific command to create this file. Go ahead and press ls, or do a ls lexicon, because that's where we saved it. I press tab, so I verify that it is in there. It's the only file within it. I'll go ahead and clear this. So now we just created that lexicon file. So we're going to go ahead and upload it to AWS. Let me just double check something real quick. Okay, we're in US East 1. That's good. I do want to show you guys something with the region, so just keep that in mind. So AWS Poly, put lexicon / specify the name that you want to save it within AWS as. We're going to give it the name dev terminology. Do a /, and then we're going to give the actual file that we want to pass up using the content flag. So again, you want to use that specific format with the file : two forward slashes. I don't remember if I named my directory lexicon or lexicons. Let's try lexicons. Go ahead and run this command.
You need another dash in front of content, I
Yep,
think.
yep, yep. This might take a minute. It's probably because we're all uploading this, we're all trying to upload the same thing. So the way it works is within your console, you can just go to the lexicons and then and we have dev terminology. So it just creates, I think it creates different versions. That's what the entities mean. Or don't quote me on that. I have to look into that. But yeah, so if everybody saved under dev terminology, there's only going to be one that pops up. It's not going to be dev terminology 01, 02. It'll always just be that one name. To double check what lexicons we have in the console, let's go back to our through our CLI. Let's go ahead and run this command, AWS poly list lexicons. And as we can see, we have Patrick's and then the dev terminology, PBJT, and then poem lexicon. We can go ahead and press Q to quit. Now we can create a more technical file that contains different keywords like JSON, PostgreSQL, DevOps, etc. The terms that we saw within that lexicon that we just passed up. So for that, just go ahead and create that technical content.txt. The text says our AWS infrastructure uses JSON APIs to communicate with PostgreSQL databases. DevOps teams manage these systems through automated deployment pipelines. End of file. So just press enter, create that file, do an ls, and it got saved within the test files directory. So do a ls test files just to verify it's there. And it is. I'll go ahead and clear my screen up, make it cleaner. Now let's go ahead and actually generate audio with the lexicon. So run AWS poly, synthesize speech, \, give your text flag with the file format. Test files directory / technical content.txt / specify your voice ID. We're using Joanna. Specify our engine. We're going to be using Neural. And then now we're going to specify the lexicon that we will be using from within AWS, which we named as dev terminology. If you uploaded something else, go ahead and use that. So lexicon names, and then dev terminology / specify our format of MP3. And lastly, specify our file path we want to save it to along with the name of the file. So audio outputs / with lexicon. Go ahead and press enter. Let me double check. There's no typos. I do not see any
Do you need a file extension or no?
file extension. What do you mean by that?
At the very end, audio outputs
Oh,
with
yep. Yeah, yeah. Good catch. Thank you. All right, press enter. And it created it. Let's go ahead and verify our audio outputs file or directory. Do an ls audio outputs. You should have with lexicon.mp3. And we do. Let's go ahead and let's create one without a lexicon. Oh, well, Joanna Neural should already be without the lexicon. So let's go ahead and listen with the lexicon and just compare it to our Joanna Neural file. Let's go ahead and code audio outputs with lexicon. And then we're going to be listening for the differences between these two files right here.
Our AWS infrastructure uses JSON APIs to communicate with PostgreSQL databases. DevOps teams manage these systems through automated deployment pipelines.
Or actually, I was just thinking we can't compare it to this Joanna Neural because they have different text. So let's go ahead and create one without the lexicon. So just go ahead and press the up arrow to get back to that last command you ran with synthesized speech, and just get rid of this specific line with lexicon names. You can do that by pressing Control K at the beginning and then pressing it again, Control K, to remove the whole line. And then after you do that, go ahead and name the file without lexicon. Go ahead and press enter. Press Q. And then go ahead and open up that new file you just created. So code audio outputs, and then without, press tab and press enter. So again, we're gonna play it without the lexicon, and then we'll play it again with the lexicon.
Our AWS infrastructure uses JSON APIs to communicate with PostgreSQL databases. DevOps teams manage these systems through automated deployment pipelines.
Let's go ahead and listen to with.
Our AWS infrastructure uses JSON APIs to communicate with PostgreSQL databases. DevOps teams manage these systems through automated deployment pipelines.
Let's listen to without one more time and with one more time.
Our AWS infrastructure uses JSON APIs to communicate with PostgreSQL databases. DevOps teams manage these systems through automated deployment pipelines.
Let's listen to with.
Our AWS infrastructure uses JSON APIs to communicate with PostgreSQL databases. DevOps teams manage these systems through automated deployment pipelines.
Anybody notice any differences? What do you guys notice?
It's actually more choppy with the lexicon.
You think so? Let's listen to it one more time. Let's see.
Our AWS infrastructure uses JSON APIs to communicate with PostgreSQL databases. DevOps teams manage these systems through automated deployment pipelines. Our AWS infrastructure uses JSON APIs to communicate with PostgreSQL databases. DevOps teams manage these systems through automated deployment pipelines.
Yeah, it could be. I can see that. I feel like the with lexicon is more like they pronounce everything more. Uh does anybody have any other thoughts on this?
I think without lexicon, it did sound smoother, like what Monica was saying.
Did you guys notice how she said PostgreSQL?
Yeah, J the words JSON and Postgres sound significantly different between the two,
Yeah, I
with the
think that's what
lexicon
it
sounding
was.
better, in my
Mhm.
opinion.
Yeah, honestly, I feel like I feel the same way. Because with lexicon, she actually says Postgres and then QL. There's a big space in between, and then I think without lexicon, she says PostgreSQL.
Our AWS infrastructure uses JSON APIs to communicate with PostgreSQL databases. DevOps teams manage these systems through automated deployment pipelines. Our AWS infrastructure uses JSON APIs to communicate with PostgreSQL databases. DevOps teams manage these systems through automated deployment pipelines.
Any final thoughts between the two audio files? Okay, then we can continue on. Let me go ahead and clear this. So now we're going to create an SSML file to provide breaks, or so you guys can see breaks as well as different uh, parameters like rate and pitch. So first one we're going to create is the SSML demo, the XML file. Then we're going to create an SSML demo to XML file. So go ahead and create both. Go ahead and do an ls test files just to verify they are both there. They are. Now we can try to generate two different audio files from the two different XML files. So go ahead and run the AWS Poly synthesized speech command /text type. We want to specify it to be a SSML file. We provide the actual text file. Do a /, select our voice ID. /, select our engine. We're using neural. And then specify our output. And lastly, our file name. Audio outputs.
Before you hit enter,
Another
typo in the first line.
Okay.
Speech.
I can't even. Here, let me run this and then rerun it or fix the typo. Is it test files? I put a SSML demo.txt. that was created. Let's go ahead and create the demo2 audio file. See if I can just modify this text file. And voice ID. Take out the engine flag. You do Control A to get to the beginning of the line, then Control K twice to delete it. And name your file enhanced to. It was created. Let's go ahead and double check it is there. ls test files. Let's go ahead and open them up. Before we actually open them up, let's create another plain text version. Okay. Actually, yeah, just go ahead and open up the demo1 and demo2 files. Second. Did I? Oh, okay. It's because I'm looking at the actual SSML files that we created. So we're gonna go to the audio outputs and check that. So do ls audio outputs. And yep, this is what we're looking for right here. So let's go ahead and open those files. No one said anything. All right. Sweet, we got our audio for the first one. Now let's go open up the second one. Okay, now let's compare the difference between the two. So the first one just has some breaks, and then the second one will have different rate pitches, or yeah, it'll have different rates and different pitches.
Welcome to our technical documentation. Critical information requires your attention. The deployment process includes 3 essential steps. Step 1, API configuration. Step 2, database initialization. Step 3, service validation. Emergency procedures require immediate action.
Notice the break times that it has. Now let's look at the second one.
Welcome to our technical documentation. Critical information requires your attention. The deployment process includes 3 essential steps. Step 1, API configuration. Step 2, database initialization. Step 3, service validation. Emergency procedures require immediate action.
If you guys are listening to the audio and looking at the XML file as well, you can kind of see better the differences in the rates and the pitches, as well as maybe different uh, 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 different ways to say something like it's spelled out API. So you can just pretty much utilize or see the differences within the tags better. Any questions or comments? Okay. Pros. You guys want to, let's go ahead and just create the plain demo, the plain audio file without the SSML real quick. So just go ahead and create your plain demo text file. Then go ahead and run your AWS Poly synthesized speech command. And for this, you just specify the text file, the voice ID we're using, the engine, and the output format. We're not putting in any of the XML files. Created it. Let's go ahead and open up the audio file.
Welcome to our technical documentation. Critical information requires your attention. The deployment process includes 3 essential steps. Step 1, API configuration. Step 2, database initialization. Step 3, service validation. Emergency procedures require immediate action.
Notice how there's no breaks and it was pretty much all the same speed. Now we're going to combine both lexicons and SSMLs. Go ahead and create the lexicon PBJT. So it just has, again, the phonetics and then the words that Poly is looking for. And yep. Now we're going to actually push it up to AWS. So if you notice, whenever you create a lexicon file, just go ahead and push it up so you can utilize it. PBJT, it's already in Amazon, but it doesn't hurt to just run through it. Again, it's probably taking a while because it's already over there. Now let's create the SSML. And we're creating it under the file name pbjt.xml. And that's going within the test files directory. Let's go ahead and run that last command to create our audio file. So we run the AWS Poly synthesized speech command. We give the file type SSML, and then we actually give the file. We give the voice ID. We give the lexicon we're using from AWS. We're giving the engine, which is neural, and our output, as well as the file name. Go ahead and press enter. Let's go ahead and listen to it. So code audio outputs, PBJT. Now let's listen.
It's peanut butter jelly time. It's peanut butter jelly time. Do the peanut butter jelly. Peanut butter jelly. Peanut butter jelly. Peanut butter jelly with a baseball bat.
Honestly, let's compare it to the other audio file that doesn't have the SSML and lexicon. I think that's it's the Matthew neural. It's kind of hard to tell the difference because whenever I hear this audio, I think about the song, but where's the Matthew? Here it is.
It's peanut butter jelly time. It's peanut butter jelly time.
It's kind of
Do the
slower.
peanut butter jelly. Peanut butter jelly. Peanut butter jelly. Peanut butter jelly with a baseball bat.
Let's look at the enhanced.
It's peanut butter jelly time. It's peanut butter jelly time.
It's louder, has breaks.
Do the peanut butter jelly. Peanut butter jelly. Peanut butter jelly. Peanut butter jelly with a baseball bat.
Anybody have any thoughts on that one?
I like
I
that
don't-
one.
I don't know
That
that I
was
would
funny.
count. So like I looked in the file and it said like it was said as loud. I don't know that I would call that loud compared to
Or maybe it was clear. I don't know. I felt like it was a little bit like clear, like just a tad bit louder, or I guess
maybe.
maybe uh they pronounce there's more pronunciation. I don't know, but that's just what I'm noticing. But we have different. Everybody has different ears, so oh, how would you describe it, Kathleen?
Yeah, it just didn't seem um emphasis. It's fine.
Yeah,
I
no,
think it's
yeah,
fine.
yeah. I get you. It doesn't really like it.
Wasn't distinct, you
Yeah,
know.
yeah. It's really difficult to tell the difference between the two. Like, especially when I hear that text, I think of the song, so it's completely off. And all right. So now, uh, yeah, it says, is it perfect? Definitely not, but we are working within the constraints of a speech synthesizer, not a vocal/music synthesizer. So audio outputs again, or here, let me switch my screen back to the lesson. So audio outputs, again, choosing various file formats will largely be up to you and your use case. You can try different file types with any of the exercises we've done up till now by changing the output format and resulting file name. If you need additional examples, you can expand this markdown block below. And then now it's just cleanup and resource management. So good practice includes cleaning up resources and understanding poly limits. So let's go ahead and list all our lexicons with AWS poly list lexicons. Shoot. We have Bev, TBJT, Poem, Kevin, and test lexicon. So go ahead and press Q. We can get more information about specific lexicons by using the command AWS polyget lexicon and then specifying the name of it. So let's look at dev terminology, see what we get back. You get a JSON with the actual contents of the file. We get the name of the lexicon, and then we have our attributes. We have alphabet, the language code, last modified, the ARN, which is a resource number. Pretty much think of it as the street address for specific AWS services. We have our lexemes counts how many lexemes/terms are within that specific file. And then this is 634 bytes for the size. Any questions? And then review generated files. Run this file to see all the audio files we've created, or run this command. So it just gives us extra information about all our audio files, size, uh, permissions, date is created, time. Let's check total size. It's 824 thousand bytes. And then this is the command to actually delete a specific lexicon. Let me check if you guys have ran that already. Let me. Okay, so it's still there. Let's go ahead and run it. Now it's gone. And then in conclusion, you've now experienced the complete AWS Poly workflow. We went through console exploration, CLI mastery, lexicon management, SSML enhancement, format optimization, and batch processing. So we understand voice capabilities and testing different options, automating audio generation, customizing pronunciation for professional results, fine-tuning speech characteristics for specific needs, choosing appropriate audio formats, and scaling audio generation for real applications. Key takeaways: voice selection significantly impacts user perception. Lexicons are essential for professional applications with technical terminology. SSML provides precise control over speech characteristics. CLI automation and enables integration with larger systems. Different formats serve different application needs. On Thursday, you're going to be building a React application that gives users web interface for the same capabilities, bridging the gap between command line power and user-friendly design. Is there any questions for the end of our lecture? Yeah, go ahead.
I had a few questions about
Yep.
what we're doing.
Yep.
What role would do something like this? Would this be the AI engineer or who would do this?
Um, I would say yes. Yes. It would be an AI engineer. I've not really dig deep into who exactly would be doing it, but yeah, I'd say an AI engineer, or maybe even just like if you're freelancing and you're trying to help out a business with adding certain features to their for example, their phone system, which I brought up earlier. If you're calling business and sometimes when a business is closed, they have a voice operated uh, message. That's something you could do, or maybe for accessibility uh, uh, issue or for accessibility, some you could create something for that for people who need audio to go through a website. I think actually I think I saw there should be a little section here that has different roles. Maybe it's in the first one.
Oh,
Yeah.
okay, yeah. Nick posted it too. Thank you, Nick. Okay, so this is good to that we need to know, get a broad understanding, right? To
Mhm.
get familiar with these different tools. But most of us will, in some way, specialize, or there are many generalists in this space.
I feel like there are many generalists
Uh,
uh, right now for this. So like, let me go back. So yeah, just like I feel like there's many like this has many different use cases. Uh, you can solve many different problems. You just got to get creative and really think of what those are. I mean, this is still new, so who knows what you could solve with this technology. I don't know if that answered your questions or if you have any more.
Oh, that was perfect. Thank you. It gives me greater context to understand it. And it's just like, hey, this is good. All these different tools, even though we're going over it, you're giving us the tools to build off that skill set, right? In case we are at a role or wanted to dive into that deeper, right? We can build off those skills. Thank you.
Yep, no problem. Are there any more questions? If there's not any questions, let me go over the challenge real quick. Objectives is to create a custom lexicon and SSML text file, generate audio output using lexicon, SSML, and Poly, which we just did, and use generative AI to assist with creating and revising XML files. Go through all the necessary steps to create one of your own projects and just mess around with it, have fun. You can I want to let's see who can make some really creative or interesting audio files, and yeah, work with one another and make sure to collaborate. If you get stuck on something, ask one of the other students. But if there's no other questions for me, this is the end of the lecture.